Let's assume an organization has decided to use GitLab as the code repository and is in search of an CI/CD automation solution. GitLab Server is an open source DevOps platform that allows you to manage your entire software development lifecycle from a single location. It provides features for version control, issue tracking, CI/CD pipelines, package registries, and many more. There are numerous tools available in the market to automate CI/CD pipelines. Nevertheless, given the organization's commitment to GitLab as the code repository or the version control system, let's explore how GitLab CI/CD offers the automation capabilities. So what is GitLab CI/CD? GitLab CI/CD is a built-in tool that helps you automate your software development lifecycle from code commit to deployment. It allows developers to automate tasks directly from their repositories. You can quickly create workflows or pipelines to implement a CI/CD job that builds, tests on every commit, and also deploys merge requests to any environment right beside your code base. So how are the CI/CD jobs executed? Runners are the agents that run your jobs. GitLab Runner works with GitLab CI/CD to run jobs in a pipeline. Out of the box, GitLab CI/CD offers two main options: software as a service SaaS runners and self-managed runners. In this session, we'll have a brief look at the SaaS runners, and later on, we'll also explore self-managed runners in a separate segment. SaaS runners are hosted and managed by GitLab. These runners fully integrate with GitLab.com server and are enabled by default for all projects with no configuration required. Your jobs can run on Linux runners, which supports a wide range of languages and tools. You can also choose Windows runners, which are ideal for projects that use Windows-specific tools or require testing on Windows systems. You can also make use of macOS runners, which is a good choice for project that requires macOS-specific tools and services. And finally, it also provides you GPU-enabled SaaS runners to accelerate heavy computing workloads for high-performance computing, such as the training or deployment of large language models as part of model ops workloads. Another advantage of SaaS runners is that GitLab manages the infrastructure for you, which includes setting up servers, scaling resources, and also managing the execution environment for your workflows. So your task is to write the workflow configuration, which is basically in YAML format, and GitLab CI/CD handles the rest of the stuff. This includes, executing your tasks within a newly provisioned virtual machine for each job, caching necessary dependencies, and also providing reports on the outcomes. Finally, the automation helps to streamline, development by releasing new features and bug fixes to your users more quickly. It can also automate your deployment so you can, reduce manual errors. And finally, it can increase the efficiency of your software by catching bugs early and often before they make it to the production environment. So how does this work? So let's just, check out the YAML file, which is used for, creating and running these pipeline jobs. So to kickstart, you will be starting with a .gitlab-ci.yaml file in your project's root directory, which contains the configuration for your CI/CD pipeline. And a pipeline is nothing but an automated process capable of executing one or more jobs. These pipeline jobs this basically run in response to specific events occurring in your repository. For instance, in this example, a simple event like committing code to the main branch of the repository is going to trigger the pipeline. And within the pipeline, you can define one or more jobs. Jobs defines what you want to do. For example, you want to test whatever code changes which you're committing, or you want to deploy, the code changes to a different environment. And a runner is a virtual machine that is responsible for running your pipeline jobs upon triggering. GitLab, as we discussed, automatically provisions SaaS runners for each job based on the tag specified. In this example, there is a job named as unit test job that runs on 3 different machines: Windows, Ubuntu, and macOS. And consequently, GitLab will provision these 3 virtual machines for these jobs. And these virtual machines are known as GitLab hosted SaaS runners. In this particular example, all the runners are provisioned and operated in parallel, and you can also change the behavior if required. So once the runners spin up, by default, GitLab runner performs a clone of the repository to fetch the latest commits. After cloning, the runners start the execution of the steps or commands which are defined within the script of the YAML file. So in this example workflow, there are 2 commands and they are executed sequentially. First, it's going to run the npm install command, and it's going to install the Node.js packages on the runner machines. And then it's going to run the npm test command to execute the defined unit test cases. These same steps are executed on all the 3 runners concurrently. And consequently, if one of the runner completes all the steps execution, it will be marked as successful, even if the other runners are still in progress of executing their remaining steps. The pipeline as a whole is marked as successful only once all the 3 runners have completed their task successfully. So during and after the job execution, if you want to access the logs, the outputs, or any artifacts for each job, you can access them via the GitLab user interface, or you can also use the GitLab REST API. So this information is basically received by GitLab from the runners where the jobs gets executed. So within the GitLab repository, you can simply navigate to the pipeline tab to inspect the pipeline status, the logs, and the artifacts. And once you go to this page, you will be finding that there is a job named as unit test. It has been executed on 3 different machines, and you can view the logs of each of them individually. This is going to allow you for detailed debugging of the workflow's progress and its results. And if the job generates any artifacts, you can access and download them as well. So GitLab provides a very convenient interface for managing and retrieving any artifacts produced during this workflow execution, and therefore enhancing the overall visibility and usability of your automated processes. So finally, in this video, I've provided a brief overview of pipelines, jobs, scripts, and runners. So these concepts will be explored in greater detail in our upcoming sessions. Thank you.